Hey, what's up, y'all? We're going to solve a common exam problem using the Clausius-Clapeyron equation, and this is it. The vapor pressure of dry ice is 672 torr at negative 80 degrees Celsius and 1486 torr at negative 70 degrees Celsius, and the question is asking us to determine the molar heat of sublimation. So before we jump into this problem here, and I show you the solution, pause the video, try it on your own, like literally pen on paper, try it on your own, and then unpause and see how you did. And I'm curious how many people can get this on their first try. Give you a chance to pause it, and now I'll show you the solution. So I like to think of a diagram here. So if we're sublimating, then we're converting solid directly into a gas. Imagine you have this dry ice in a closed system. When the solid and the gas form an equilibrium together, the pressure of that gas is this pressure right here, the equilibrium pressure. Okay, so to determine the molar heat of sublimation, we're going to use the Clausius-Clapeyron equation, or a similar form of that. So this is it, except here we're using the enthalpy of sublimation instead, and this is in its integrated form right here. So from here we can plug in our values. We can plug in one of the pressures. I just chose P1 to be 672 torr, and then T1, rather than negative 80 degrees Celsius, we need to convert it into Kelvin. P2 is the other pressure and the other temperature. Make sure it's in Kelvin, and we want to choose the R that has joules in it, not units of pressure, but joules. And if we plug that in, we get an enthalpy of sublimation, standard enthalpy of sublimation, of 25,890 joules per mole. We usually report these in kilojoules per mole. And notice that it's positive, which means the process is endothermic, which means that it takes energy to convert the solid into a gas. Cool beans. I've got tons and tons and tons of work through exam problems that you can try, help you with your exams, your assignments, all of that stuff. Hang in there. You can survive. Cheers.